All right, we used to say, hey, what is 2x minus 3 when x is 5? And you would plug 5 in and go, oh, 2 times 5 is 10, 10 minus 3 is, 7's the answer. Well, how do we say it now that we're in high school? We would say it like this. We'd say, hey, f of x is equal to 2x minus 3. Find me f of 5. Evaluate the function when f is 5. So this is called function notation. We've seen this before. It's nothing new. So let's look at a few problems. We have f of x equals 4 minus x, and g of x equals 20 minus x squared. So question 1 says, hey, find me f of negative 5. Plug negative 5 in to the f function and give us an answer. So if we were doing this, we simply know, oh, it's 4 minus whatever x is. Well, what did they give me for x? Negative 5. Well, we know a minus and negative is going to change to plus, and we get an answer of 9. Well, what about g of negative 3? We go to the g function. It says do 20 minus whatever they give you, which is negative 3, and square it. Now notice, we got to square negative 3, so we need to make sure we put parentheses around that negative 3. This will end up being 20 minus, well, what is negative 3 squared? 9, and 20 minus 9 is 11. You have to be careful. Some students would make the mistake of doing this and just changing that to a plus and then doing, oh, it's 20 plus. That's wrong. Don't want to do that. If I'm squaring a negative number, I always put it in parentheses. What about this one function? H of x is the opposite of x plus 4 divided by x squared. So it says find me h of negative 4. So it's the opposite of x, so the opposite of negative 4 plus 4 all over negative 4 squared, because we replace that x with a negative 4 and that x with a negative 4, which is what I've done here. Opposite of negative 4, that changes to plus 4 because the opposite of negative 4 is positive 4. So the top gives us 8. Negative 4 times negative 4, positive 16, simplifies to a half. When we did problems like this last chapter actually, what did we do? We said, hey, that and that cross out and we just get x plus 4, but we make sure we say, hey, x can't be a negative 3. We need to let people know that, right? You remember that? Well, we said x can be anything in this problem as long as it isn't negative 3. In other words, the domain, the values that work for this guy, we can plug any x in except him. So as we say, the domain is all real numbers. Any number works except for negative 3. So domain is describing what the x can be. Now, domain is what the x values are or can be. The range is what the y values are or can be. And I remember that sort of like going to the doctor. X comes first, then y when we have an ordered pair. So this x value is your D, domain, and y is your R, your range. So let's consider these three numbers, okay? These three, ordered pairs. We have the ordered pair 2, 3, 4, 5, and 8, 10. The domain, in other words, what are your x values? Well, this is easy as can be. 2, 4, and what? 8. So I say 2, 4, and 8. The range are your y values, which happen to be 3, 5, and 10. So we just say 3, 5, 10. Domain are what your x's are in the problem, and your range are what the y's are. Here, domain. 2, 4, 9, 11. 2, 4, 9, 11. Piece of cake. Well, what about the range? Well, we have a 5 and a 5. I only need to list it once. An 8 and an 8. I only need to list it once. No sense in listing it twice. So the range, the y values are at 5 and 8. Now you're like, well, hold on a second. That's a little weird. Can I have that back here when I'm saying weird? You're like, hey, when it's 2, you get 5. When it's 4, when you get 5. Well, let's just look at a real life example here. So movie ticket. Let's say that to go to the movies, ages 7 and under, it's $5. Ages older than 7, 8, 9, 10, 11, so forth, are $8. So if we plot that, Well, let's think. Age is 7 and under. So here's 7. So if you are 0 years of age, how much are they charging you? Technically, they're charging you $5. Well, what if you're 1? $5. 2, it's $5 for a 2-year-old. $5 for a 3-year-old, 5 for a 4, 5 for a 5, 6, and 7. So basically all these ages from 0 to 7, and even all the way up here almost to 8, doesn't include 8, because if you're 7 and 364 days, you're paying $5. Well, what about if you just turned 8? You got to pay $8. So the price for an 8-year-old is $8. For a 9-year-old, 10-year-old, and so forth. That would be sort of like this and continuing. Notice the domain, what the x's can be. The x's go from 0 forever, okay, 0 all the way to infinity. What about the range? Notice the range is only $5 or $8, while the domain continues forever. Well, we'd assume you can't get past 123, maybe is the oldest person ever. I don't know. Look it up. 117. Actually, it's probably closer. Guinness Book of World Records. You go to it. You let me know. Now, function. The definition of a function is that for every x value, there can only be one y value. So when x is 2, there's only a single y value that goes with it, maybe 8. You can't say, hey, when x is 2, you get 8 and you get 9. You can't have that. Because when you plug in to a function, when I plug in a 2, I expect to only get what? One answer. Some answer comes out maybe 9. I can't plug 2 in and get 8 and 7 and 4. So for every x you plug in to the function, you should only get one y value out. That's how we describe what a function is. So let's say we're plotting these points. Would these be a function? I'm going to say no, because notice when you plug x being 2, you get an answer of 4. And here when x is 2, you get an answer of what? 9. So you're like, oh, f of 2 gives me an answer of 4. Well, wait a second. No, it doesn't. You also get an answer of 9. That can't happen. So no, this is not a function. What about this? When x is 2, you get 4. When x is 3, you get 4. When x is 7, you get 4. That's okay. That's just like the movies. Maybe at 2, 3, and 7-year-olds, it's $4, $4, $4. That's okay. For every x, there's only one y that goes with it. When x is 2, there's only the y of 4. The y's, notice, can repeat. It's just the x's. You can't have an f of 2 and get 2 different answers. Here we have f of 2, f of 3, and f of 7. The x value is being plugged in. You got an answer of 4 for each. That's okay. What we usually have is we have this vertical line test when we're looking at graphs. So if I have, like, when x is 2, you get 1, and x is 2, you have 3. Notice that when x is 2, you have a value of 1 and 3. You can only have one y value. So this is not a function. And we would notice that if we did a vertical line, that it goes through it more than once. We use this usually when we have a graph. If I have a graph that maybe goes like this, we're like, hey, is that a function? Well, the answer is no, because if I put a vertical line, it crosses in more than one spot. So the answer to that would be no, that graph is not. And you should have done that in Algebra 2. Let's say we have a graph that goes like this. Yes, a parabola. Notice that passes the vertical line test. No matter how I put a vertical line on here, it's only going to cross in what? One spot. So that would pass, and that would be a function. Remember, a function, for every x value, there can only be one y value. There you have lesson 3.1.